And good morning. So I'll be starting the live stream in just a moment. I'll just give it a few seconds for people to join the stream. It's very kind of you to join me today. It is of course 5 a.m. in Japan, so I am quite sleep deprived as usual, but we'll see how things go. Hopefully it'll go pretty well. Firstly, I'd like to issue an apology for anyone who tried to join a stream on Sunday. There was not supposed to be a stream on Sunday. I set up the stream wrong. It was supposed to be scheduled for next Saturday, but I obviously didn't set it up right, and it was scheduled for Sunday, and I didn't realise, and so maybe one or two people were waiting for a stream that never occurred. As I say, very sorry about that. It certainly wasn't my intention. Generally speaking, the streams on my channel will be this time on what's a Friday morning in Japan. Saturday afternoon, probably going to be moving that to 7 p.m. shortly. That's on a Saturday, but in the UK that will be Saturday morning. And then occasionally I will do a midday stream, and that will be whenever I've got time off work, if possible on a Wednesday, but otherwise maybe on another day. But if you see a stream on a Sunday, there's probably something, I've probably set up the software wrong again. I do apologise about that. Okay, so today I'm going to be trying to disassemble the game Phantasy Star. Now, I don't usually do a disassembly. It's not something I find easy. It's my opinion that if you can't code it yourself, you're probably not going to understand what you're seeing when you're disassembling. But this was a request from a Patreon who were interested in this game. So I thought I'd better try and do my best on this one. So we're going to have a look at the game. I've already got it pre-set up in a different emulator. Can't use my usual emulator. We're going to be using Mecha today to disassemble this Sega Master System game. So let's go ahead and let's just make a start here. So hello there. I'll just change a setting quickly on my streaming software here. So I apologise for the rather small window. This emulator. Sorry, just clearing my throat there. This emulator has made the rather unusual choice of well, that's not fair. It's made the choice of so I'm just checking my live streaming's working okay. I'm getting some errors on my phone here. I don't know if everyone can see me okay. Maybe it's just my phone that's failing. If anyone's having any problems, can you comment in the chat, please? I'm going to assume that everything's okay and carry on. My phone has lost the connection though. So we're going to be trying to disassemble this Phantasy Star game here. Now the Patreon in question was interested in sorry, just let me apologise for a moment. I just need to double check this stream's really going. So my phone, I usually watch my stream. Okay, it looks like my phone just spontaneously crapped out on me there. Okay, it looks like the stream is going okay. So so the Patreon in question was interested in this Phantasy Star game, and they wanted to know about how the 3D maze sections worked. So that's what I'm going to try and investigate today. So I've downloaded the ROM. I had to have a look at a video online because I've never played the game, so it had to get to the stage where I could actually see what the part in question was. Fortunately, it's fairly close to the start of the game. So if what we've got here is we've got the game screen here, this little window here, and we've got the tiles here. So we can see what graphics are being built by the system, and hopefully from that we'll be able to work out what is actually going on. Okay, so if I go into this little room here, we've got this maze, and then if we press the direction keys, you can see we can move around this maze here. So this is it's difficult to know what to make of this. So the this is of course the master system. Here we go. There's a door here. Just looking at the tiles and how they change in memory. So, I mean, we can see as we get to this door here, it gets bigger smoothly, but then the staircase appears very abruptly. No. And so we just came straight back out again. Okay, so I must have just turned a full circle there. This is of course the first maze in the game, so I'm not sure. Maybe there's nothing in here. Maybe this is just it. It might just be a test. Well, I'm certainly grateful for it. I didn't want to have to play hours of this game to get to the scene. So you can see there that that wall just immediately appears very abruptly there. That's quite surprising in a lot of ways. It's quite understandable that that would happen, but now, the first thing that's sort of occurring to me is I had assumed when this was mentioned to me about this game and this sequence, I thought they'd programmed a wireframe rendering engine, and that they were using the tiles and real-time rendering a wireframe display onto the screen, because on the Amstrad CPC, for example, a game that showed a sequence like this would be doing that, and that would, don't get me wrong, be very difficult to do, because you'd have to have sorry, I'm just going to cough again, excuse me. Sorry, I do have the remnants of a cold, so I'm having to mute the mic quite a few times here. I was thinking they'd be using a wireframe rendering engine because that would allow for smooth graphics, as long as the rendering engine was fast enough, of course, and using very little storage space. And what you would see here would be that, what I would expect to see rather, is that the tiles would fill the entire screen, and there would be a lot of repetition because it's all been calculated in real time. But that's not at all what I'm seeing here. I mean, for example, you can see here that there's this area of the black fading out bit, which isn't being used on the screen here. So, well, why is it in memory? I mean, that's certainly not indicative of real-time rendering. And that, well, that's nothing like what's being shown on the screen at all. So, it seems more like there's this kind of like trembling effect. Okay, so yeah, it's using different, the tiles in memory are changing. You can see these areas here are being changed as you're moving forwards and backwards. But the repeated areas, they're reusing the tiles, which, I mean, you wouldn't think if it was being calculated, if the tiles were being calculated in real time, you wouldn't expect that to happen. If they were being rendered by a wireframe rendering engine, I wouldn't expect that. I mean, it's not impossible, but it could be some kind of combination of the two. Like they've got formulas to calculate the tiles, but then they're using a tile map, a predefined template tile map for the frames of animation. I mean, that is possible. I'm just trying to see. When we move in, I'm just saying, is it this part here that's drawing this wall here? And then it would be this part here that was being used for this. Right, okay. I was just, you know, if the distant part is going from dark green to light green, you know, you'd expect an area of the tile map to reflect that. So, I mean, it looks like what they've done is they've got a set of banks of tiles here predefined, and then as you're moving around, there's different banks for the different frames of animation, and then they're changing parts. I'm going to cough again. They're changing parts of the visible display to select parts of that tile map, because I say, why is this shadowy part even in memory at the moment when it's not visible on screen? It's in memory at every stage here, actually, except for the rotation. So that rotation is very different. And then that one, I mean, look at all of these parts here. Are these that door that we saw a moment ago? Let's go back to that door. Was it over here? I can't remember where the door was. Maybe it was up here? No. Here it is. So, I'm just going to take a screenshot here. Bear with me a moment while I sort my windows out here. So let's have a look. So that's what the tile map looks like at the door. And it's the same there, isn't it? So let's go back to the start of the maze and let's see if the tile map is the same again. Because I think they've got a very small set of possible... Here we go. Yeah, yeah, it's identical. So you know, what they've done is they've got multiple tile maps that they're using at different stages of the rotation and the movement around the maze. So that's one there, and you can see that looks to be the same as this one here. But there is no dynamic. They're not dynamically changing any of the tiles at all, I don't think, which is quite anticlimactic, really. I was expecting something. I was imagining that the moving parts, you know, these forwards and backwards parts, were some kind of wireframe rendering engine, and it was only the sort of close-up bits like that door that were pre-rendered. That was what I was imagining it was going to be. So let's have a look at this thing then. Get rid of this, we don't want that. I assume that this kind of alternate graphic interface where all of the windows appear within a special sub-window exclusive to that application, I assume this is for portability so that it can be converted to things like Linux and not have to worry about the OS specifics themselves, which would make a lot of sense in that context. So okay, I have no idea how to use this debugger. I should have really okay, so we hit enter to move. Okay, just a moment. Evening, Robert Lee. It's very kind of you to join me. You think it seems like it's loading the tiles ahead of them being used. This code here. possibly. As I say, this disassembling code is not my strong point, unfortunately. So yeah, I'm gonna have to. I am winging it quite a bit here. So what we're doing here then? So the LDI is going from A0EA, and it's going to D. Okay, so that's going from ROM to RAM then. Okay. So I guess, is that copying the... If it was copying the tile map, that should be going to VRAM, shouldn't it? It's very, very kind of you to join me, Tad89 and Robert Lee, incidentally. Yes, I just spotted you on the chat there. Thank you for joining. I'm just trying to work out. I mean, it's looking to me like this is using predefined templates to build the screen up from predefined tiles. It doesn't look like there's any there's any major real-time calculation going on, which is quite a surprise. But it's quite probable. It's quite probable that there's some kind of compression going on of the tile map data. You know, maybe the tile layout is being calculated in real time, at least for parts of the screen. You know, like maybe the top and bottom of the screen are being read from a template, and then the middle part here is being calculated. But I mean, honestly, personally, I'm not going to be able to work that out in a plausible amount of time from the source code. I mean, I say there could be hundreds of lines here, and working out what it all does is going to be very tricky. So what I'm hoping is that any code that handles those large sections, you would expect to be being run a lot of the time during the system memory. I mean, this is a very... What's it doing? It's loading from the A memory range, and it's writing to the D memory range. So it's reading from the ROM and writing to the RAM, and I'm wondering if this is building up the tile map. But there would have to be some point where that data was written to the VRAM, and that would be being done by some out commands. So let's see if we can... So I think this is some kind of... and it's copying some memory, and then there's this jump if parity even here. And if it is, and if it is, then it's jumping back. So I'm not sure why that is. I'm wondering if this is an RLE compression routine or something. So so that it's so it's allowing it to reuse the same source byte again. That would make sense. Just trying to remember what the parity even's not really a command I've really used very often, you know, to be honest. It's there's my Z80 list. On the 6502, the overflow flags are set automatically by the top bit when you read it in, and I'm just wondering if they're using like the top bit as a as some kind of counter. I'm not sure. So this is one, as I said before, this is one of these ones where you kind of have to second guess what the original authors are trying to do in a lot of cases, and the only way you can do that is if you basically are at the same level as them, i.e. you know the best way of coding a system like this, and if you do, then why are you bothering to look at their source code is kind of the problem. Anyway. So it loads in A. It loads C from A. So that's C into A an increment. I'm sorry, being pretty dumb here. I can't work out what this is doing. Okay, so it's setting. Okay, so it's setting. It's reading in A. It's reading in the number of bytes to copy. And then Morning, Guy. It's very kind of you to join me. You recently started backing me as a patron. As I said in the Patreon, first, it's very kind of you to do so, but your name is now on the list, the scroller list, or your web URL. I did take a quick look at your website. It's very looks very promising. I gather you're looking to start doing a lot of programming and some assembly programming. So please make sure you let me know about that, and I'll be keeping an eye on Twitter for any assembly related content, and I'll be trying to share that. I don't know what you're looking to cover in your programming series, but one thing that is something I think I don't really cover very much, and I think is something that is probably needed quite a bit, is firstly more stuff on the use of basic and assembly together. You know, where stuff's done a lot in basic with just little bits of assembly, because I think that's something that will help a lot of people. And so I'm just about to cough again. And also things relating to the real hardware, because that's something I don't cover at all. So how to make disk images, how to transfer, you know, games from an emulator to an SD card and run them on real hardware. I don't know if that's anything you're planning to cover, but if you did cover it, then I'd be certainly interested in sort of sharing that out there and linking it in on the forum and things, because as I say, it's totally lacking on my content at the moment. But anyway, as I say, I'll be keeping an eye on what you're working on. It looks like you've got some big plans there. It'll be interesting to see. So anyway, I'm trying to work out what this code's doing, and my 5:30 a.m. brain is too tired to do it. Sorry, hang on a minute. This cold's not giving me a rest. I did see you covering the 3.5-inch floppy. That's I didn't see you were mentioning the disk images. That's definitely interesting. Yeah. Well, if you do any kind of stuff like that, please feel free to post it in my forum in the Amstrad section. It's the forum is exclusively assembly language, but it's really supposed to include anything that would be a programmer would need. It's not a series for basic tutorials, but it is for basic tutorials on using BASIC with assembly. And equally, I'm not planning to. The forum isn't really for hardware problems, but if the hardware problem is getting your game onto the real machine, then okay, no problem, Guy. I'll be here until 7 o'clock or so, I think. I'm not sure how much progress is going to be made because I'm really messing with this assembler. But as I say, you do what you need to do and just come in and out, and I'll still be here anyway. Okay, so the PE, I think that's a special thing for when the BC reaches 0. I was overreading that one. 2, 1, 0. Yeah, so sorry. It's been so long. I've been doing so much 6502 and things. I'm really not as sharp on Z80 as I should be, but I think the PE is a special flag that's set when the when LDI reaches 0 in BC. So that was just a counter for BC. So it's been it's done a loop of the source data there, and now it's checking if it's got to the end of its data table. And then it's masking the bottom byte there, which is a counter for C, and then it's repeating again. So essentially this is copying large chunks of data up to 128 bytes. I'm assuming this has got to be a graphics routine. I'm just stopping the code randomly because I don't know anything about what this code does, so I don't know particular memory areas are relating to graphics or joystick or sound or anything. So I'm just stopping it and taking a guess. But one would presume with a game that's got a very visually active section that most of the code that would be using the processing power at that time would be relating to the graphics, and thus just stopping the code and checking it out. Hopefully you would find a part that was relating to the graphics. So we'll just see how things go. So I'm just let's just tick through here. It's very repetitive, but this kind of code is going to be. So we can add breakpoints here. We might need to do that later. Can we scroll the window up and down? Maybe not. Now, Now, just in case you're not aware of it, I mean, I'm debugging this in memory, but the alternative would be to sort of load the cartridge into a disassembler. But the problem with that is the disassembler can't tell the difference between code and data, so it will misinterpret the bitmap data of the tiles and the player sprites and the sound and things as potentially code in a lot of cases, and that will end up with you will end up with nonsense code, and you usually have to go in and tell the disassembler, oh, well, this area of the code is not code, it's bitmap data, ignore it, and things like that. So it's not, there's no to my knowledge, there's no magic solution to this kind of thing where you can just push a ROM file into this thing and it will output a fully disassembled, easy to read piece of code. You know, as I say, you basically, when you do this, what you end up with is when you're disassembling someone else's code, what you're ending up with is the result of all of their work without their code commenting. So it's heavily optimized. It could be very hard to read. Hello there, HH. Very kind of you to join me. We're trying to disassemble Phantasy Star today. I'm just trying to work out how these 3D sections work. So I'm sort of saying, so far, from what I can judge, it's using a set of predefined tile sets for so it's okay. So I'm kind of guessing from the name, but I'm a bit hazy on how names match up between all the platforms. Unfortunately, it gets very confusing. So it's using. I was saying, if you look at the different scenes, there are multiple tile data pattern sets, and it uses different ones for different frames. But if you look at the same frame position in totally different sequence scenarios, for example, you know, this one with the door here and this one without the door, the tiles are identical, even though what's shown on the screen is completely different. And then as you rotate, you see all of these different tiles here. But as you can see here, once again, this is completely identical to this, even though, well, there's no reason for the door to be in memory anymore. And if I walk, you can see here we've got this this black area here, but that's not visible on screen again. And if we walk up to here, well, the black area here is still visible in the tile map, but it's not shown on the screen. So I think what they've done is they've created this set of maybe 10 banks of tiles for the different frames of animation. You can see, I don't know how many there are there, I can't count them that quickly, but they seem to have a relatively limited set, and then they've built up these scenes. And the scenes themselves are effectively pre-rendered, which is surprising me because I was expecting it to be wireframe. I thought it was a clever wireframing rendering engine, and that which was a nightmare to me because I'm terrible at maths, and I don't think they've actually been that clever at all. I think what they've done is they've created an optimized set of tiles that can be used for creating wireframe 3D environments. And then they've written some kind of compression routine to allow for those tile maps to be. Sorry, I'm coughing again. To be stored in memory without using a polar cartridge, essentially, because obviously the cartridge, you know, the screen is quite big, and so you're storing all of the tile map is not an insignificant amount of data. So and I guess they're going to be having to handle the flipping as well of the tiles here as well. So I'm now been going through the code with the debugger, and I'm not great at debugging, but I thought it was worth having a go, just having a play around and see if I can work out anything about how the data is being built up and stored. And I don't know if there's a key press for. Here we go. This is interesting. So we've got an out I command here. So BE. Okay. Well, so now we're outing data to BE, and BE is the VDP data port. So this is quite hopeful. So with any luck, where's the data coming from? The source is 8A 3B. So let me just get a notepad up here. A 3B. Okay. So BE is the VDP data here. Oh, I'm wrong. Oh, sorry, it's not RAM. 8A is game code, so it's copying from game code here. Okay. Because the data, the routine I saw before was transferring from the game code, the cartridge, to the RAM area at A. No, where was it? No, it was copying from A. It was copying to C or something. So maybe I'm not sure what this is. Let's continue looking and have a look at it. So it's loading the counter from A, and then it's loading A from HL. Altai doesn't use HL, does it? Altai. So it's being used as a mask. I don't quite understand what it's doing there. Okay, so BE. Sorry, I'm completely lost as to what this is doing. And if anyone can tell, so it loads in A from the data source, and the data source is the ROM cartridge. It checks if it's 0, and if it is, it returns. So that would be the end of whatever data it's looking. It's using 0 as an end marker, and then it's loading in a counter from A. So if the counter is 0, then it returns. But if it's not, then it's going to process. It loads in the accumulator from the data source. Then it transfers the same data that it loaded into A into the BE port, which is the VDP, the video data port. Then it inks B. Now, I don't know why it does that. some of the systems have to do that because because they use a 16-bit data port, but I don't think that, if my memory is correct, the Master System doesn't do that. Sorry. So why is it doing that? And then it outs A. That's just baffling me. And it could be some kind of compression routine. You know, there could be something to do with that. They could have worked out some formula for the order of the tiles, and that has allowed them some kind of compression by merging multiple together. You know, for example, if they know that one tile is always going to come immediately after another in consecutive order or something, but I can't quite work out what they're doing here. Oh, well done. Good to have you back, Guy. As I say, we're just looking at this code, and I'm just trying to make some kind of sense of it, and unfortunately it's escaping me. It's almost certain that the developers of this program are far smarter than I am, so me looking at their uncommented code isn't likely to be an amazing success. But yeah, I thought we'd better give it a go. I only resort to looking at trying to disassemble people's code when I'm desperate, basically. As I said before, if I know a way that I think I can produce a similar result, then I will produce the result in the way I can work out, rather than trying to steal knowledge from the gods, so to speak, and try and disassemble someone's code and then use that, because it's like, well, you're going to end up, if you somehow pull it off, you're going to end up with a piece of code that you don't really understand, and you're then relying on, whereas writing a simple piece of code you do understand yourself is, in my opinion at least, going to be easier. But as I say, sometimes, in this case, as I say, HH made the request of wanting to know how this worked, so I'm trying to answer that question. And in other cases, it's just simply because I have no idea how to do what I want to do. When I was doing the tutorials on the Sam Coupe with the audio, I couldn't figure out how to make the audio work, so I did have to do some disassembly then. Now, thinking about it, I'm just, why are they writing 3 bytes to the VDP data? Can we see on here what the VDP data port is? If my memory serves me correct, the Master System uses 2 bytes per tile, and the one will be the tile number, and then the second will be the extended tile number, because there's up to 512 tiles, and also palettes and things like that. And so it would make sense for there to be two writes to the VDP, one for the tile number and one for the palette and the extra tile number by bit. But why are the three here? It's a Z80, so it's little endian. I say, just why is the three? Why would there be three? All to the same port. A being 2 there. I mean, one thing they're going to have to do is they're going to have to flip the tiles. The screen image here, if you look here, you've got these curved sections here and here. And just a second. And if we go to my tutorials here, so we've got this vertical and horizontal flip here. So 2 would be the horizontal flip. Yeah, no problem. No problem, Guy. Just give me a moment. I just need to get my brain in gear. Yes, yeah, exactly. HH, yeah, you're spot on there. It's got to be using these two here. It's got to be setting these two. It's got to be. It's the only way it can be doing it. I just don't understand why we're doing 3, because here you've got A, F, and oh, A is 0. That's the flag, isn't it? I'm familiar with this debugger. So it's outputting a 0 there. Okay. But yeah, there's not enough tiles here to be building up this without flipping. So this corner here is got to be being flipped for here, and then flip for here and flip for here. So there's got to be some provision for that flipping in the code. Now, one possibility is that the tile map within the cartridge memory stores all these areas, but that's very unlikely. There's got to be some serious compression going on, because the sheer number of, 1 byte per 8 byte square for the tile map, that's going to be enormous. And as I say, it would actually possibly have to be 2. So there's got to be some kind of compression going on. It's always 0 here. I mean, I'm assuming this disassembler is working okay, because AF. I mean, AO seems to be 0 in this sequence, so I mean, I would have expected it to change a little bit more than that. Actually, I can. It's filling the tiles here. So I just noticed it. It's actually updating the tiles. Okay. I'm not being unobservant here. So it's actually drawing the new tiles into the tile map, into tile data from the source. Okay, so let's run it through here and see what happens then. So it wasn't occurring to me that the screen would be updating on the fly. So at the moment it's defining what I will refer to as the patterns. So we got the patterns in memory here that define the tiles, and then the tiles here. So we'll just keep sequencing through here. Unfortunately, this seems to be a text-based one. So if I want to add a break... sorry, hang on a minute. I'm coughing again. So if I wanted to add a breakpoint... Get that cursor back here. If I wanted to add a breakpoint on that 6BAB, then I would type B and then I'm not sure what. Possibly a W for right, maybe. I don't know. And I don't know how to remove it if I do that. I'm going to skip off doing that just for the moment. This is part of the reason I write my monitor tools on my tutorials for all of the new systems I'm learning, because using debuggers on an emulator there's usually a certain amount of studying and skill required to use them properly. And when you're jumping between systems all the time and using different systems every day, you don't build up that skill, and so you just end up fumbling around like this kind of thing. So we're into. I'm guessing maybe we're now doing the tile map itself. So maybe if we keep an eye on that screen up the top, maybe we're going to see some changes this time. That's my guess. So we'll see set 02. So no, sorry, I'm completely talking rubbish there. So we're building up memory again here. So DE is D047. Data in D047. And it's coming from 8B38. So I'm trying to build up some kind of idea of what the parts of the code are roughly speaking doing. So as I say, D047 is part of our RAM, and 8B38 is part of our ROM. So we appear to be transferring data from RAM to ROM here. So my hypothesis, and it is nothing more than a guess, is that maybe we're building the tile map up in RAM here, and then we're going to transfer it to ROM once we're done. Well, so to VRAM, although that might be wrong. Why would we build it up in RAM first? So A is 6 here, so we're going to transfer 6 bytes. I'm just wondering why is there that and 7F there? Why is it masking out the top bit? Okay, now the what is M? I forget what the M flag is. Do I have that written on this? Oh, terrific. This my cheat sheet here is using different terminology. I don't even know what the M flag is. I think I'm going to take a wild guess here, and I think that the yeah, Guy, that's my guess as well. That's all I've got at this stage. We're working on guesses. That's what we're doing. So I think the M flag is checking the top bit. And if the top bit is 1, then it's jumping to here and it's stripping out that top bit. And so this is... So we've got 2 copy routines here based on whether the top bit is set or not. Yeah, I see what this is. This is an RLE routine, run length encoding. So what we've got is, depending on if the top bit is 0, it's copying n bytes of data. So if the byte is 0, 0 is kind of the end of the file, the end of the data. But the data itself is something like this, where R is RLE, yes, no, and N is number of bytes. So if we're doing RLE, then it's copying bytes that are all the same value, and if they're not, then if it's not, then it's copying the same byte over and over again. This is a common thing. Chibi-Akamas does this, but it does it at the Chibi-Akamas does it at the nibble level for the compression, image compression, and the reason it does it at the nibble level is because a 4-color screen works more efficiently in that way. But it was a right pain to code. I didn't want to do it that way, but that was what was needed. So yeah, this is some kind of compression routine. So it's uncompressing this RLE into RAM. Now my only remaining question, I say I totally understand why such a routine is common. My only question is, why are they doing it in RAM rather than straight to the VDP? Now it's possible that they're doing that. This is a common thing, and it's not actually. It might be that a lot of the data of the game is compressed and stored in ROM and then decompressed into RAM. And I guess maybe this is actually a script that's going to be more complex later. So we're compressing. Sorry, I'm going to cough again. Because as sort of HH said earlier, there's 2 bytes per tile, so the data is going to be more complex than just a bunch of 1s and 0s. It's got to have they're just a bunch of tile numbers. It's got to have up to 512 tiles, one presumes, and also it's got to have the ability to do flipping. So it's got to be working with a pair of bytes per tile, although that's going to be relatively inefficient when it comes to RLE compression, because RLE compression works when there's consecutive bytes that are all the same. I mean, what they could do, what I would be thinking of doing at this stage, if it was me writing this, is storing these 2 parts separately in 2 separate tables, because this data might be quite continuous and this data might be unneeded most of the time. You know, you're probably going to need a few flips. You know, you're going to need to flip your graphics at this point and at this point, but for all of this area you're not going to need any flipping. And then maybe it looks like they are using the full 512 tiles to some extent at least. I don't quite, they seem very similar, but I'm presuming that they are using both. And so maybe you would need at some point, maybe for this door, for example, you would need to start using those extra tiles. I'm just looking at it, trying to figure it out. Actually, it looks like maybe it's all in there. But anyway, it's I will presume for now that it does use all 512 tiles. But the point I'm making is maybe the RLE data it's decompressing here is not the complete data for the tile map, and maybe that's why it's decompressing it into VRAM, because it's going to do some more work at it later. But again, as I say, I'm purely speculating here. So we'll just keep scanning through here. Oh. When I was writing Chibi Akumas for the CPC the first game, it was very... there were a lot of times the game wasn't working properly at all. It would crash a third of the way through a level. And you know, as I got better at programming and as I got more experienced with it, you started to get to the point where you would get the machine would crash and you would think, oh well, there's some weird colours on the screen on the spectrum. That's bound to be the stacks overflowed and corrupted the screen memory. That would be immediately what you'd think, and you'd know that would be what it would be. Or you'd say something like, well, okay, the machine reset, so that's probably I've pushed something onto the stack and forgot to pop it off, because that often causes that kind of crash. And when you're at that stage, things are quite good, because you don't end up doing this, basically. But in the early stages, before you'd started to sort of think that way, and before you'd started to understand your own code in some cases, or at least I had this problem, often it came down to this, which was just sitting there, holding down the enter key for half an hour, waiting for the machine to crash, and then the machine would crash and you'd be like, I didn't see what went wrong there, something it crashed and I don't know why. So you'd do it again and again and again, and eventually you'd spot, you know, the code had jumped to the totally wrong section of code, and it was because part of your code had overwritten the memory and inserted a jump statement that wasn't supposed to be there or something. And it was really tough. It was really tough to do to debug those kind of problems back then. And that's one of the reasons I do recommend people try WinApe if they're just starting out in assembly, because having the label names in there and being able to put breakpoints in and having mouse interface, as I say, this looks like it's got some fairly powerful breakpoints, but having to type in the breakpoints each time is very slow, and it can be, you know, this was one of the problems on the Spectrum emulator. Coming from the Amstrad to the Spectrum, I'd keep typing B, I think it was BR or B for adding a breakpoint, and then to put an AND symbol and the address that I wanted to do. But the Spectrum emulator didn't recognise the AND symbol. So it would create a breakpoint at the address 0, which is completely wrong, and then it would start complaining about... No, it would put in a breakpoint at the current address, and then it would start firing up breakpoints all the time, and it was just like... something that trivial, it just wastes so much time. It really was wasting ages, and it was just like, well, it's like, you know, this isn't the disassembler I'm familiar with, and it was kind of, it got to the point where it was like, it was quicker for me to just sit there and think about the problem until I figured out what could be causing the crash than to actually debug it with the disassembler, because it was just so slow because of my lack of familiarity with it. And again, this is where I am today again, because I've never used this debugger before. I knew it existed because I had to download this emulator before this video, because I had no tool to do this job basically. But so anyway, I'm going to keep skipping through this code then, and I'm going to wait until I start seeing that screen update, because it's got to, at some point this tile map has got to start updating. And one presumes that if we could see the tile map change in real time, we're going to see the the actual tile display update as well. So we'll just keep skipping through here until some action occurs. Hopefully it will. It's got to transfer a lot of bytes of memory to fill that screen, so it shouldn't. If we're stepping through like this, it shouldn't happen so fast we miss it. Although the change could be quite subtle, of course. Yeah, it's funny though. You think of your 4 megahertz processor and you laugh and four megahertz, that's pathetic. We got 4 gigahertz now, blah blah blah. And then when you're trying to debug a 4 megahertz processor and you realise, well shit, that's 4 million commands a second. I'm gonna have to step through up to 4 million commands to see one to see 1 second of code. And okay, I know it's not really 4 million commands. It's because it's like there's more. Some commands take longer than 1 tick, of course, and things. That's it. But the point I'm making is disassembling what even an ancient processor like this, does to just draw 1 screen onto the display. If you sat there with your calculator and tried to work it out, you'd be there for the rest of your life. So, or at least I would. So, as I say, it's I mean, when you've done this kind of thing, you gain a sudden respect for the humble Z80 and the 6502 with their 4 and 1 megahertz processors, because, as I say, the amount of actual mathematics and the complexity of it in some cases is staggering. I'm actually quite relieved at the way this is doing this, because I was worried it was going to be more of a true 3D rendering engine, like a wireframe engine, sort of like if you think of the Star Wars game, which had the vector lines, and also the Freescape engine, which was full 3D rendered. I'm no good at mathematics. I got a E at A-level mathematics, and I had to retake mathematics at university because I failed it the first year. So I'm no mathematician. So the thought that I might have to start looking at a Z80 based wireframe rendering engine was blowing my mind. So I'm quite relieved that it's actually something more down to earth, and I think it's Guy, I'm going to start covering the 650 the 8086 next year. Now the 8086 is of course 16-bit still, but there's not much has changed over the years. If you follow the 8086 course and then you looked at a 32-bit processor, I don't think you'd be particularly surprised. There's the differences, of course, but the instruction set has been improved, not redesigned. And with the 64-bit, I don't think there's that much difference. Again, they've changed the registers and things, but again, the commands are structurally very similar. There is a lot of differences, but there are loads of new registers. But new registers is just the registers went from 1 to 5, and now they go from 1 to 50. It's not a totally. It's not like going from Z80 to 8086. There's more difference in Z80 to 8086 than there is in 8086 to 8386 and 8386 to 64-bit. It's definitely different. Don't get me wrong. There's a lot of new commands, but it's like comparing the Game Boy to the True Z80. The commands are different, but it's roughly speaking the same language. I did do some disassembly of. I was having some trouble with the Sinclair QL emulator. The author had put a time bomb in the code, and it was shutting itself down on me while I was trying to do my tutorials. And I disassembled it, and I removed the time bomb, and that was with virtually no Z8, with no 86 experience, and that was 8386 or Pentium code. So I'm just saying it's not as terrifying as you would think, but I'm not planning to cover 64-bit at any time soon. My tutorial next year is going to be 8086 and 8186 for the old DOS machines and the WonderSwan. And we'll be sorry, coughing. and we'll probably mention the 386 at some point, but I'm not planning on going crazy on it. Now, I don't know what's going to happen next year with my tutorials. Up until now, I've been covering a lot of systems on each CPU, whereas next year, I'm going to be covering a lot of CPUs and not many systems. And that's really because it's getting hard to cover the systems, the amount of research time it takes. And as you get more obscure systems with less documentation, it becomes harder. So I'm focusing on covering more CPUs and less systems next year in the hope that I can attract people who are interested in ARM programming or in x86 programming to the series. And then I don't know what's going to come of that. And I'm also going to do 6809 and 65816 and hopefully time permitting and things. And again, I don't know what's going to come of all that. It's possible that I will, start then covering more Z80 systems or something, or it's possible, if there was huge demand for the 8086 series, then maybe I would start looking at 64-bit. But I think the thing with 64-bit is I don't really want to cover any system in assembly that it isn't worth knowing about in assembly. So things like the PowerPC architecture and ARM, the newer ARM architectures, the vast majority of people aren't going to have any interest in programming a modern PC in assembly because no one, unless you're doing embedded hardware, no one programs in assembly anymore. They all use C. So that's part of the reason I'm focusing on the very old machines, is because, well, this was what we programmed in. This is what I never programmed in this is what people who program DOS machines program them in. They programmed in assembly in a lot of cases, at least in the early days of the CJ machines, which is what I'm going to cover. Whereas these days, the only people who program in assembly are people who are making embedded hardware, really, I think. And I'm not even sure to what extent that's true even. No, I'm not going to do a series on writing your own driver for your own, router or something. And I think that's really the last usage cases of assembly these days will be, writing low-level hardware drivers. But as I say, I do think it's fascinating to see what your modern processors still have in them. And there's a program I found recently that was a 64-bit debugger. I was using Ollie Debug, which I think is obsolete, but there's an alternative one which I can't remember the name of. And you can see all of the registers. You can run your little program. And hang on a minute. Sorry, just wiping my nose there. And you can run your program, and then you can debug it and just see what's actually going on. And as you say, Guy, there's a terrifying number of registers these days. It's quite fascinating to see, but it's an interesting. Right, okay. I've done a little bit of PHP, but only a very, very small bit. I've done a few things over the years. I mean, professionally, I've always done sort of a lot of very relatively basic stuff. I mean, the company I work for, it's often just simple short-term solutions to problems. A report's needed that's not going to be needed for very long, or a small program needs to be written and it's written in Access because it's only a small a patch fix, so to speak. So I maintained an ASP Classic website for some time, and I have done some small PHP programming for the intranet, but not for the external network. Personally, I've learned C#. All my current programming from my tutorial series is in C#, and I have done some C as well, but I've never done either of those professionally. Those were just curiosities. Now, I don't dislike C. My only slight frustration with it is that when you're programming C, really, in my mind, what you're programming is a set of libraries that have been provided for you. If you want to get graphics to the screen, you're using some kind of graphics library. If you want to get 3D on the screen, you're using a 3D library. And if you're using sound, you've got the sound library. And if those libraries are the same, then everything works the same. But if you're porting to a system and those libraries don't exist, or they've been made obsolete, then everything you previously knew has gone. And all you're really left with is the simple stuff of pointers and structures and the definitions of loops and things. And then you can learn that in a few weeks. So really, all of your skills and all of your ability is just in these libraries that if you learned it on Linux and now you're programming Windows, well, that knowledge is gone. And if you were programming on something else, okay, no problem, Guy. I fully understand. Yep, take care. I'll probably be finishing off in half an hour anyway, so very kind of you. Yeah. And so as I say, it's like I had this little game. I had this little program I wrote many years ago, and I tried to recompile it more recently on Linux, and it turned out all the OpenGL libraries I was relying on were just obsolete, and you couldn't compile for them anymore. Oh, okay. Tad, JavaScript. I've dabbled in JavaScript. You may notice I always have a web browser with JavaScript disabled in it. I use a couple of web browsers, and one's always got it on. Wherever possible, I browse the web with JavaScript disabled, and it's been quite funny. Sometimes at work, someone will be like, have me work on their machine, and I'll be using their machine. I'll go, God, your web browser's slow. What's up with your machine? Why is it slow? Why is everything so? Why is your performance so bad on your web browser? And then I realise it's just the JavaScript grinding their websites down to a halt. Whereas because I'm used to browsing it with it disabled, it's like I don't see it. But JavaScript, I had to play with it. At one point, I was thinking of writing a little online game, and I was going to do it in JavaScript, and I was quite impressed by what it could do. But I'm not sure. I mean, there's a good reason why my website's very simple and doesn't use it. Let's put it that way. I would like to go back to the sort of early 2000 times when websites were a bit more simple but had a lot more information on them, whereas now they seem to be very complex and have very little information on them. I've been known to break out into random shouting fits at work because I'll have gone to a large company's website to find some information out about their services, and you go to the information page and it just has 8 lines of text on a full screen, full HD monitor, because the entire website was designed for a phone. And it's like, yeah, I actually want a full breakdown of your terms and conditions here, and you're just giving me nothing, and it makes me extremely angry, and I start shouting. But that's not JavaScript's fault. It's just modern website design's fault, with everyone dumbing everything down to the point that you can browse it on a 4-inch iPhone with your thumb. So I did prefer the days of the of websites that actually had large amounts of information on them, designed for people with with a monitor and reading skills. But history has taken another path, it seems. So we're still filling this RAM here. It's going on forever. It shows how much memory it takes to do things. Be honest, I've been chatting away and I've not been paying attention to the screen anyway, so it's probably a good job. Tad89, what do you think of this new WebAssembly thing then? If you're disappointed with JavaScript, what do you think of that? So it's my understanding, my limited understanding, very admittedly. You're keeping as far away as possible, okay. because there are some quite nice assemblers online that are, not assemblers, sorry, emulators online that are emulating common systems. I'm guessing they're using that, but okay, oh, this is interesting. So now we've got to wait. So we're waiting for. Rob, I don't even know what TypeScript is. I mean, is that an alternative to JavaScript? Because does that, is it called Go, the one that Google created, that they claim, oh, it's thousands of times better than JavaScript and blah blah blah. It's just like, I don't know. This is a trouble. And this is one of the reasons I've sort of, I'm trying to champion assembly a little bit. It's like all of these languages are changing and being developed and being replaced so fast that anything you are learning, you're probably not going to use for very long. And the trouble is, it's like, it's like at one point my employer was thinking they wanted me to write a new website in PHP, and you think, okay, I'm going to have to really swat up on PHP, and then the tide changes and they decide to buy in a solution, and now you're looking at all these obscure, your sort of Ruby, Rust style languages that uses instead, and it's just like, well, if I dedicated my entire educational history to learning PHP, I'd be on a road to nowhere now. Whereas, as I say, if you're learning, okay. Fair enough. Okay, Robert. It sounds interesting. From what little I remember of JavaScript, it was very strange that there was no kind of definition of the objects. I'm used to your sort of your C mentality of saying, right, well, this is an integer, this is a string, this is an array, this is an image, and I don't think JavaScript had any of that from my memory. But which, as I say, you can understand in a closed loop system, but when you're doing it on a web browser, that seemed very very insecure, because say it's not like it's running on a local machine with no risk of compromising the code. When you effectively, you've got the author writing the code and then the end user running the code, and you just don't know, can you trust either of them, kind of thing. I don't know. So we've got this wait here, which I assume is waiting for VBlank, maybe. Yeah, I mean, Tad, I mean that was my experience. They taught me almost nothing at uni. I mean, it was just like, oh, well, this week we're going to learn C. Oh, this week we're going to learn Lisp. This week we'll learn Smalltalk, even though it's been obsolete for 500 years. So thank you, thanks for that. I'll really get a job with that one. Now the problem I had is when I left university, I sort of got a fairly mediocre grade, unfortunately, which is totally my own lack of enthusiasm, I'll admit. But if you're a bountiful prospect for the employers, they're going to be willing to train you. But if you're a fairly mediocre average person, which is what I am, then they want someone who can hit the ground running and get stuff done. So what I ended up getting a job based on my ability to build PCs and based on my ability to write access databases and my ability with Visual Basic, all of which I learned myself and none of which I learned at university. And it would have been nice if if the balance had been a bit more towards a skill that can get you a basic job in the IT industry. And at the time, none of the things they taught me really did. It was just just a bit of paper. But that said, the big benefit of getting the degree is that you need a degree to live in Japan. Okay. Yeah, I mean, Rob, that certainly sounds like good advice. I mean, the first problem I had is the school I went to originally, the sort of the high school, as it's called in the UK, which was up to the age of 16. They did have an A levels, as it was called, 16 to 18, and but they didn't have anything with computing in it, and so I actually had to leave that school and move elsewhere, and it just meant you didn't necessarily have the sort of chain of recommendation and advice that maybe I think I don't know about other people, but for me it felt like being into computing. It might okay. Oh, that's excellent. Okay, yeah, Rob, that's really the ideal situation, isn't it? Yeah, that sounds good. But I mean, it's kind of weird because I'm not that old in the grand scheme of things, but when I was at school, computing still seemed to be somehow, because as I say, it wasn't that long ago. It was late 90s. It still seemed to be something that the schools hadn't caught up on. Like they still, it was still it was some kind of revolutionary new thinking kind of thing, and it was like, well, I could have understood that in the early 80s, definitely, but as I say, it just seemed a bit crazy that in the sort of mid 90s, as it was, that the school I had didn't recognise computer science or computer programming as a viable career. Learn C++ through a YouTube channel. Oh, that's terrible. That's not right. That's awful. I mean, by all means, recommend alternative sources of education, but in addition, yeah, that's great. Yeah. Go to your uni degree, you sit down, and they just turn on the laptop and just walk out. Yeah, that sounds well. Yeah. What can you say? C++ isn't too bad, Rob. I mean, I don't think it's it's certainly not worse than assembly. I mean, it's I don't know. I mean, I guess it's difficult to judge these days because I personally find I mean I'm doing C# mostly these days, and I've done object-oriented C for the iPhone at one point. Now the one that I really have the one that really annoys me is what do they call it? Visual Basic Sharp or whatever. VB.net, sorry, VisualBasic.net. That's what it's called. I'm so annoyed by it. I've forgotten its name. Visual Basic 6 I quite liked. I programmed Visual Basic for DOS at one point and Visual Basic for 6, and I found those quite pleasant and quite reasonable things to do as in terms of developing a programming language. They seem quite nice programming languages, but when it came to VisualBasic.net, they seemed to think, like, well, okay, we want to make an easier to program version of C#. Okay, we'll do that. Of C, sorry, C++. Okay, well, we'll make C#. And then they seem to think, well, we got to keep doing Visual Basic. So let's put all of the functionality of C# into Visual Basic, even though most of it's never existed before. Make up a new set of commands that don't match Basic or C#, and make Basic as complex as C#. And it's like, well, you've not helped anyone. You should have either just transferred the new commands directly as is, or just not put them in. Because either you should say, right, well, Basic users time, you can keep using your current Basic, but you need to level up. Otherwise, we can't give you more functionality, and the best way for you forward is C#. Or they should have said, well, okay, here's this hybrid of the two, and you can keep using your basic commands, and you can use your C# commands for the new functionality, and then if you want to migrate to full C#, you just give up on the basic bit. But it didn't seem they did either. Okay, C++. The only C++ I've done, Rob, is on Linux, really. That's a complete lie. I just told a complete lie there without realizing it. I did do some. I've done C++ twice. Thinking about it, I did some Linux programming. I wrote a small video program, a video compressor and a decompressor, and I ported it to the Nintendo DS, and that was done in Linux. But I did do a game a long time ago, and that was in Windows, and it was a DirectX. It used Direct 3D. And it used OpenGL actually. It was based on those OpenGL tutorials that are very popular, and it used It used an iToy webcam for camera motion. So it was just a little pet project I wrote. But I say it's so long ago I've forgotten about it. But yeah, I've done both. Yeah, well, as you say, Tad, the problem is the libraries. Everything, once you start using the libraries, everything is just about that particular library and how that particular library works. I mean, I say my previous experiments with it have been the video thing. I used SDL, or I think I used GLES as one point as well. But as I say, it's. I don't know. It's quite difficult. And with regards to Rob, with regards to the Windows era, I have very briefly looked at it's programming in C++ Windows applications, and it looks quite complicated. It looks far more complicated than programming in assembly somehow, which is quite an achievement, really. But anyway, it's I can't comment on that kind of thing. I've got no experience of it. I don't know if it's the case that the sort of historical underlyings of Windows are so poor that things are overcomplicated, or if it's just that. Sorry, let me just work out. Wasn't there a command? Oh, it scrolled off the screen. I couldn't work out where the command was, but it scrolled off the screen. Sorry. I didn't realise the screen was scrolling as I was doing all of this. So this is some kind of timing code here, I guess. I mean, that's certainly my feelings, Tad, on assembly. And the thing with assembly as well is you don't have to worry about the libraries, because the systems I'm programming, you can just do it all yourself. You know, you don't need a graphics driver to program the Sega Master System graphics hardware. You just go straight to the hardware. I have no idea what this code is doing. Yeah, maybe. I mean, it's reading, it's setting a memory address and then it's reading from that memory address. So I guess the sorry, excuse me. So I guess that the interrupts are changing that memory address, and so this is waiting for that interrupt to occur. Maybe it's that interrupt drawing the screen though, so maybe we need to wait it out. Is it 3.8, the interrupt handler? Yeah. Okay, so that was that's a lot of outs there. F80. So this RST is selecting a video address then. Okay, so is this setting the sprite table, I think? That would make sense, wouldn't it? It's not the range that I'm looking at for my tile data. This is some I think that's sprite data, but I might be wrong. Now, usually I finish these at 7 o'clock, but today I do have a day off, so we're going to run it a little bit longer. I'm not sure if we're making any progress here or not. So I'll keep going for another 20 minutes or so, and then if we're not making any progress, then I will call it a day. I might have another look at this off camera and just see if I can work out anything else. Might just need a lot of cycling through the code until I can find the part that does the graphics, but hopefully I'll be able to come back with some kind of update on what it's doing. All these outs to 7F80. To VRAM address 780. Okay, so this time it's 7F00. What's that? Now, you need to set the 7F isn't the full memory address, because the top nibble, the 7F part is partially defining that it's a writing. Okay, so it's a sprite table again. Okay, so it seems to be doing them in 2 sets. That makes sense. So this is an unwrapped loop, obviously. These all these out eyes here. I mean, this is probably game logic here. Okay, Ted, I fully understand. I think I'm going to call it a day as well. I don't think I'm making any particular progress here. I think I need to just tick through the code for enough time to figure out what's more of it's doing. So what I'll do, I'll have another look through the code. I'm probably not going to do another video like this on this. I'll probably post an update on the forum, and I'll link the update if I have one on the comments of this video and things. And I think what I need to do, I need to have a think and try and work out a good way of compressing data, tilemap data. And I'll say we'll do some kind of proper tutorial on this system on tilemap compression or something, or tilemap animation. I don't know what it'll be called yet. So thanks everyone for watching today. It's been really kind of you as always. I really appreciate it. I'm not sure we made much progress here, but this is what doing this job of disassembling code is like for me. Someone more experienced would probably be better at it, but that's what it is. Thanks HH, very kind of you to join me, as well as everyone else. I hope it was of some interest, and we'll see what we can come up with for a better tutorial later on. Thanks for watching, and goodbye.